Yes, hello, thank you for having me. Like my friend said, my name is Matthieu. Name Riegler, German name, French first name. So, I'm a software engineer in France, and my nickname on the web, French, Jean-Mèche. Today, I'm going to talk to you about change detection. I think one of the hardest topics to master in Angular, and some things have changed recently, so I wanted to share the new things that happened. So, what are we talking about? Change detection is the process through which Angular checks to see whether your application state has changed, and if any, the DOM needs to be updated. And it's one of the parts that's, let's say, the costliest in Angular. So, change detection costs a lot of performance. Knowing how to master change detection will help you master performance. In Angular, when you do change detection, it starts, if I can get this away. Yeah, perfect. It starts at the top when your application ref just sends, let's say, an event, and it propagates through the whole application depth first. So from the top, every component is going to be change detected. Boom, 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 boom. From the left to the right, bottom at the end. So that's what happens. First question is, how is it scheduled? Because that's how Angular determines when we need to change detect the whole application. And this is done. This is done thanks to Zone.js. You probably heard of it, probably had a nightmare with it. But basically, Zone.js tells Angular when the app is so-called stable. So nothing is happening, you can update the application. And for this, we have an observable that we can listen on microtask empty, and when it fires, Angular knows the app is stable, we can trigger the application ref.tick. Exactly. So, first question, how do we optimize change detection? And for a very long time, we can do OnPush. OnPush, for no who knows what it is, it runs change detection only in certain conditions. The two major ones are when the reference changes on the input. That means if you do not use immutability, you won't have the change detection. And the second one is when you call mark for check, and that's exactly what the async pipe does. So when you use OnPush, you get better performance, but you need to determine when your application will be change detected. So how it would look like, it's you still have the same tree. With the black border, we have the OnPush components. And for example, on the right, I have the dirty ones. And these are the ones that will be change detected. So in the middle, the gray ones are not, because they were not dirty. And on the right, the ones that were dirty. The ones on the left are not OnPush, though I checked what we call check always. So every time there is a change detection that starts at the top, there will be change detected. So, what are the responsibilities of change detection when the framework runs it? 4 points. First, just execute the template to know what to update. So the new value to put into the DOM. Also, change detection is responsible to call all the life cycle hooks you know, on init, after view init, after content init, etc., etc. It also updates the queries. The queries are content child, content children, your child, your children. And the last one also updates the host bindings. That's the one that allows us to have an action to, let's say, update the classes or something like that. These are the, 4. And since v17, we have a new hooks after render and after next render. So the other 5 responsibilities, let's say, of the change detection. But when we do change detection, there is also a responsibility toward the developer. It is unidirectional data flow. It is necessary because we don't really know when, let's say more, where the changed and what happened and where. When I mean unidirectional, it's, remember the tree, it starts at the top and goes down. So always from the top to the bottom. So a component down the tree should not alter the rendering of one of his ancestors or any other rendered element into the component. Do you know what happens if you do not do that? I think you all know. NG100. The most famous error, everybody had it. And that's what happened when you actually change something after it was rendered. So yeah, you break the basic rules, the framework screams at you. And it is hard to fix. It's, when you look at it, it's one of the most viewed help videos the Angular team has. So much questions on Stack Overflow everywhere. Everybody had this issue, mostly when you do forms. So let's build a small form. Those who were in Vienna 2 weeks ago will recognize some of the slides. I stole some of them to Alex Rickerbar from the Angular team also. So let's take the idea, we'll build a model-driven input. It will look something like that. Let's say we display a status of our model, and we have two inputs that will modify the state of our model. So first, we have an input where we put some forbidden characters, and below just the value for our model. So what happens is when you modify here, it will have an impact on the value and on the status. That means if you modify here after and something that alters the status, you will get the NG100 error. So that's how it's look, the basic example in the template. We have first the interpolation. We've got the first label where we get the reference, and we put this into the input. The details are not really important. What I wanted to show is that when you modify the forbidden characters, it will trigger the error. So, do you know if we can fix it? And actually, how do we fix ExpressionChanged, the error? There's one famous fix that you probably already used, and I'd like to hear it. Who knows that?
Promise resolved.
Yes, more or less, either promise resolved or set timeout. Our beloved. And you know what? It's used by everybody. When I mean everybody, this is ng form from the Angular framework, and if you look at here, we got a nice resolved promise. So even the Angular team knows and uses the same fix, because when you modify something that is, let's say, stateful from the DOM, it's the DOM that pushes the value to Angular. Then you have the problem, because you've got data that comes from the top, but also from the bottom. So Angular in itself already breaks the rule. So it's not only your fault that we get the error, it's also the framework's fault. So first problem. Second problem is you still have it's using OnPush with this kind of implementation. For example, you had another component that's 100% OnPush. If you pass the model to the component down here, if you do not change the reference, for example, the model is just changed its value inside, your component will never get refreshed. That's one of the issues. So can we fix all of this? All the issue we have with change detection? And the answer is, of course, signals. If you do not love them yet, you will soon. If you know a bit about signal, one of the important things about signals is the signal graph. So the kind of hierarchy we have between the information. If we take our example, we get our producers. So signal are like objects, functions you call, but also that will emit some values. You subscribe somehow to them. So in our case, we got two producers. We got first the input where I put my string, and the other one is the illegal characters, so the second string. That's both the two producers we have. These producers are consumed by a computed. The computed just listens to the values by calling them, and every time they change, it will be called and produce a new value. So it's a consumer, but a computed is also, most of the time, a producer to another consumer. And here, the final consumer is the template with the string interpolation. So here we have a nice example of a simple signal graph. Producers, some mixed consumer producers, and some kind of end consumers. We like to call them so live consumers. They always listen to the value. So one of the core concepts and the basic idea that you need to understand is Angular understands the signal graph. So it means Angular is able to profit from the structure and to know which value change and reflect it to the DOM with change detection. And one of the first improvements we had with signals landed in v17. It's a technical concept that you will not see directly as a developer, but it's important to have to know when you want to understand change detection. Traversal nodes are actually components that will be traversed during change detection, but not change detected. So first, with signal, we'll be able to still have our change detection like before, starting at the top to the bottom, but some components are going to be skipped. And here my example is I've got a component that is dirty. So I have a dirty signal. It means the signal has been changed somewhat, somewhere, maybe by the signal store. So first thing what happens, component is dirty, and automatically the parents are marked as traversal. So these components are going to be the one that will not be change detected. So if I trigger change detection somehow, application ref calls the root component, our default component is still change detected normally, and should have been another arrow on the left. But then what happens? Here on the right, I've got a non-push component that is traversal. And here, we'll see that the component will not be change detected. But the dirty one will be, and then change detection continues normally. We have below a non-push that wasn't changed, won't be change detected, and the last one is a default one that will be. So here we see that with signals, the framework is able to know which component to re-render and the one that he doesn't need to re-render. So here we got a major performance improvement by just updating the components that have dirty values. Major breakthrough. So I'd like to show you a small demo. Some of you probably already saw it, and it's here. It's a small demo where we have a component tree where you can do some different actions. For example, here, that's what I told you, I can do can increment change of signal value. And when I do that, you will see a first thing. So here, what you see is that the component have a flag. The first one down is dirty, and the parents at what we call has child views to refresh. That's an internal flag that tells Angular, traverse these components, you do not need to check them. And first thing you can notice, there's a green banner up there. signal updates will not trigger right now change detection. It will soon, but right now it doesn't. So first thing we need to do is trigger change detection. And here what happens, you see all the blue components were the one that were change detected. I can block it if I do this. Okay. And here you see that either on push or default, these components are not re-rendered. Only the one here down that was dirty that was re-rendered. So we are already able right now, v17 without Zoneless, able to just re-render some of the components. That's one of the key things that Signal allows. Having a signal tree allows the application, also allows the framework, Angular, to just render what it needs. If you want to play with it, you can scan the QR code. It's, you can see on GitHub. That's one of the key things. And what I can also show you is also clear. Yes, of course. I can zoom if you want. It doesn't work. Reset. Oh, I broke it. What? Here. And it shows you what Signals does, but every other action you will see, you have. You will see the difference you have when you do only a Markov check, the explicit call to detect changes. If you detach or attach a component, etc., or just a simple click. So, for example, I do a click here, and you see, when I do a click, every parent of the OnPush gets dirty. Different from consumer dirty, we have a dirty flag that tells the framework this component is on push and dirty, refresh it. So that's the small demo first. And next. Next, I wanted to talk about Zoneless. Zoneless is an interesting topic. It's about dropping the nightmare that Zone.js is. To go zoneless right now, the key things is we need a new scheduler. Right now, the scheduler was Zone.js that allowed the framework to know when the application was stable. So we need a new scheduler that doesn't rely on Zone. And currently, the Angular team is experimenting with different solutions. I've seen some implementation with request animation frame, so it just checks regularly if there is something dirty, just trigger change detection, or another one based on macro task with set timeout. I've seen a PR that was opened a few days ago. Basic implementation, not much more than, let's say, 10, 15 lines, something like that. It just calls, every signal would call the notify, and if there is something, a task already scheduled, it will be skipped, and if not, it would just trigger a change detection. Basic implementation. So you see, you would say, if it's that simple, why don't we have it yet? It's because change detection is only one part of what Zone.js does. And Zoneless should also take care of not breaking the concept of stableness. And stableness is really important, typically for SSR or the router. Imagine SSR needs to know when the application is stable, so it can just say, I'm stable right now, just send all the HTML to the browser. One of the key important things. And also, when you do testing, you do not want to break the way change detection works automatically in the tests, unit tests, I mean. Official Zoneless support is likely, and it insists on likely, to be in preview in 2024. Don't at me on this, but I really believe that we get some previews early 2024, and let's see how the year will end. And one last thing I want to talk to you about when you do change detection is track by. Track by, you know it from the NG4, but we also have it now in the new 4 block with the new control flow. Who really knows what the track by does? Are you really sure to know, if you know it, what it does? I thought I knew. I didn't. I have 10 years of experience, and I've learned things like 2 months ago when they changed it. So I want to share it with you. That's with the new syntax, how it looks like. Do you have any idea between the two differences you have here with the two examples? First one, we use the index here. The second one, it's what we call identity tracking. So when the reference change, you get something that happens. Do you know what happens when you do that? Those who follow me on Twitter have seen a demo I've shared here. I've got 2 examples. The first one, I'm just doing focus on one line, and then I trigger some sort asynchronously. And what you see is that somehow the DOM is stateful. And I focused on the value 8. Something happened. The table was reshuffled or sorted, like here. And the value that was selected isn't anymore, it's another one. And actually what happened is Angular just kept the element and changed the value. That's what we call the binding. Other case below. Here, I just created a list, and I've got, as you can see in the code here, I just put the content directly in the DOM using create node. And if I reshuffle, look what happened. Angular only changes the binding. The key element is to understand here, when you use tracking, also element tracking, that when you track, the track item binds the item reference to the element in the DOM. This means if the reference of the value, when I mean the value, when it's a primitive value change, it just swaps the row or deletes it and recreates it. And the example I showed you, it's when I used the index. So when I used the index, it just saw that the element didn't change. So index 1 was still index 1, index 1, index 2, etc. But we just updated the binding. So the element was kept, and we just updated the value. And one slide too fast. Immutability. So when you do reference tracking, immutability implies that each time the reference changes, the element is deleted, recreated. So it means that's what tracking identity, which was default in NG4, meant you were doing reference tracking. You were creating and deleting the elements of the DOM every time. And this is actually the most costly things in Angular, accessing the DOM APIs, creating an object, deleting it, etc., etc. So if you have a long list that shuffles regularly and the items are not tracked or not correctly tracked, like you've got immutability, then you will get poor performances. And the case with index that I said, it rebinds the data with the item. So it's actually a good default, but like in the demo I showed you, it's not always the best one. And what I would recommend, if you can do it, is actually bind to something like an ID. You pass an ID directly. No need to create a new method in your component. You can directly pass directly in the template, and right here you would have, let's say, probably the best performance for your component. So these are the key ideas really for mastering change detection. Knowing that right now you can get the best performance with signals. And if you use signals today, you will be able to go zoneless, actually, quite easily. You will be able to have these new change detection that skips the components that are not changed. and etc. So thank you, everybody. If you have some question, you can maybe ask them after. If you want to follow me, I share a lot of technical stuff and internal stuff about Angular on Twitter. Thank you, everyone.